Hi, so today we are going to talk about hypothesis testing and statistical tests. We have two types of hypothesis. The H naught or null hypothesis states that there is no statistically significant relationship between two measured variables, like exposures and outcome, or there is no statistical significant difference between two studied population. Then we have the null value, which is the number for null hypothesis. One is for ratios like relative risk and odds ratio, just means that numerator is equal to denominator if the ratio is 1, hence there is no significance. Similarly, for differences, we have 0, like attributable risk or absolute risk reduction. Then we have alternate hypothesis, which is denoted as H1, which states that there is statistically significant relationship between two measured variables or differences between two studied population. So I have a question here which states a group of investigators plan to conduct a study to assess the relationship between hypertension and smoking, involves determining the prevalence of hypertension based on cutoff values and smoking in a sample of individuals at same time. Prevalence of hypertension is compared with and without smoking history, which is the best statement for null hypothesis. You may want to think about this question for a minute and you may pause the video. So the answer to this question is there is no association between smoking and hypertension. If you really think about it, you will understand that the rest of the options kind of denote the results after the study is actually completed. Then we have the type 1 versus type 2 error for the hypothesis. I try and remember them using this 2 by 2 table. So for the column, we have the null hypothesis to be true and false, and the row says the null hypothesis to be accepted or rejected. If the null hypothesis is true and it's accepted, we make the correct decision. If it's false and we reject it, we still make the correct decision. If the null hypothesis is false and we accept it, we make a type 1 error, which is denoted as alpha. And if it's true and we reject it, then we make a type 2 error, which is denoted as beta. So alpha is the probability of type 1 error and it's usually set at 0.05. Beta is the probability of type 2 error. So if we subtract beta from 1, we get the statistical power. If we increase the sample size, we can increase the power. So p-value, a very important thing, is the probability that the result of a statistical test will be at least as extreme as the result actually observed, assuming null hypothesis is correct. The p-value, if is less than equal to alpha level, then it's statistically significant. Oftentimes in question stems, the alpha level is not stated and we assume it to be 0.05. Then we have the statistical tests, which are used to either reject or accept hypothesis. This is the 2 by 2 table. I would recommend for everyone to learn to make the question solving easier. So variables can be either classified as qualitative or categorical, like gender or blood group, or quantitative or continuous, like temperature and age. Depending on that, we can determine which type of statistical test to use. Dependent variable usually are the outcomes, and independent variables are usually the exposures. So if both of them are qualitative, we use chi-square or logistic regression. If dependent is qualitative, independent is quantitative, we use logistic again. If both of them are quantitative, we use linear regression. If the dependent variable is quantitative and independent is qualitative, we use either t-test, ANOVA, or linear regression. T-test is usually used if the sample size is like 2, and ANOVA is used for more than 3 sample size of dependent variable. I have a question here, pretty similar to the previous one. So a study was conducted to assess the association between smoking and hypertension with 200 patients. We have 2 by 2 table here. Which of the following is the best statistical method to assess the association? So you may want to pause and think about it for a minute. So to reach the answer to this question, I'll come back to this 2 by 2 table and we'll determine what are the type of variables we have. So we have hypertension and smoking. Both of them are qualitative variables. Hypertension is the outcome, so that's a dependent one, and smoking is the independent one. So the answer will be chi-square. It's pretty simple. Just an add-on point here, the t-test, we use the 2-sample t-test to find the difference between the means of two groups. It can be the paired or unpaired. Paired is the same group sampled at different times, and unpaired are different groups sampled at same times. That's it. Thank you.